Mr. Client for Client Maths, National 5 Applications of Maths 2025, Paper 2. It was Friday the 16th of May at 10:20 to 12 o'clock, so an hour and 40-minute long paper. I think the paper was reasonable most of the time, but let's get into it and see what we thought actually. National 5 Applications of Maths 2025, Paper 2, Question 1. The body mass index is calculated in kilograms for mass and height in meters using this formula, mass over height squared. That's actually the real formula. A patient's mass is 93.5 kilograms and the height is 182 centimeters. Calculate the BMI. So, try to trick you here. Centimeters, but it's meant to be in meters, so I need to divide that by 100 to get 1.82. So the BMI for this patient is 93.5 divided by 1.82 squared. And we get a calculator obviously to work that out. 93.5 divided by 1.82 squared is 27.319. Or about 27.3. And we're done there. SQA National 5 Applications of Maths, 2025, Paper 2, Question 2. Aisha earns an annual salary of £46,900. Following a pay deal, her annual salary is increased by 1.7% for each of the following 3 years. What's her annual salary after 3 years? So I need to do 100 plus 1.7 to get 101.7%. Divide that by 100 then to get 1 point, using a calculator to be on the safe side, 1.017. And that's my multiplier because this is just appreciation. So it's 46900 times 1.017 to the power of 3 to give us 49332.79. The three significant figures then, with a pound sign, cut in here, so I'm rounding down, 49300, and we're done there. Clever Maths is sponsored by Lecky, the educational publisher for Scotland. Today we're going to look at practice workbooks for National 5 and Higher Maths. These are just £5.59 when you use the discount code CleverMaths at leckyscotland.co.uk, and these are excellent because they have lots of questions topic by topic by topic. So as you're working through the year, you can revise and practice any topic you want and make sure you are comfortable with that topic. But also when it gets towards exam season, a practice exam paper right at the end to make sure you're ready for your exams. Just £5.59 when you use the discount code CleverMaths. The links are in the description and down below. National 5 Applications of Maths 2025, Paper 2, Question 3. Alistair works in a factory that makes chocolate and he's got the results in a table. Number of people that like chocolate, different types. Draw a pie chart. So if we're going to draw a pie chart, first thing we're going to need to do is get an angle. So to get an angle, you do each number divided by the total. So if we add up these totals, 34, 44, 54, 60, 80. So divided by 80, fraction of an amount. And what's it of? Well, it's of 360. Because 360 degrees in a circle. So I know the answer to the first one, but just for everybody, 20 divided by 80 times 360 is 90. That's my first angle. 34 divided by 80 times 360 is 153 for my next one. And then the last one, 26 divided by 80 times 360 is about 117. So then we're going to draw that on our pie chart using a protractor and a ruler. So I've got my protractor here, so I put the cross in the middle, line it up through the zero, and I'll zoom in for you in a minute. And then we go round on our protractor until it's at 90, so I'm going through the outside scale because the zero's on the outside, go round to 90 and put a little mark. Then you're going to get rid of your protractor and drawing it up with a ruler. So I'm on my little mark, I've put my ruler down next to it, and I'm just drawing it up to the outside of the circle. And then you can get rid of your ruler because you don't need it anymore. And you can label that bit now or do it later. I'll label it as we go. So that one was white chocolate. And that was how many people? 20. So I'll put 20 in there. I'll even show the angle, but I don't really need to. I'll put it in. Put everything in it I possibly can. Okay, moving on to the next one, 153 degrees. So this time I need to turn my protractor around to go along the new line, and then I need to line up along that new line as best you can. So we go down good enough there. So 153. We're still on the outside scale. So we're going all the way around to 150. And then adding 3. I'll put a little mark. 1, 2, 3. Now this mark will look quite big on here just because I am zoomed in. But there you go. You put your little mark. You then get your ruler and join it up to the centre. So there's my little mark. So I'm going to join it up and get rid of my ruler. I mean, technically, you don't need to draw anything for the last one, but it's worth checking. So I'm just going to put all the information in from the table again. Milk chocolate, 34. And we can see that that was 153 degrees. So I'll just put that there, 153 degrees. So the next angle should be 117 degrees. And it should be dark chocolate. And that was 26 people. So we can just check it using our protractor to see if it actually is 117 degrees. There you go, that's as good as I'm going to get. It's meant to be about 117. And you can see that I'm on the outside scale all the way around 115, 16, 17. Yeah, I'm right on 117, so I'm quite happy with that. So in terms of marks for this, it's worth 3 marks. Usually, if you look at previous papers, you get a mark for calculating your total, a mark for calculating your angles, then a mark for drawing it with labels. Labels is probably just enough to have dark, white, and milk chocolate. I like to put the numbers in as well. I like to put the angles in just to make sure they'll cover all bases. SQA National 5 Application of Maths 2025, Paper 2, Question 4. Alana earns £800 gross pay per week. National insurance is calculated in the pension's pay before deductions such as pension. Calculate Alana's national insurance payment. So Alana makes 800, which is in the middle of this bit here. So I'd start off, I don't ever get to here, I just go to 800. So I do 800 minus 242. Now I need to work out 8% of that. Now a nice tip for this is you can do times 8 divided by 100. But it's actually probably nicer to get used to turning that into a decimal, so 0.08, which is done by just doing 8 divided by 100 in a calculator. Because if you ever do a higher application of maths, you times by decimals all the time for percentages. So it's worth getting used to it now. So there we go. So then I can just do that sum all in one go on my calculator using brackets to my advantage. 800 minus 242 times 0.08 or times 8 divided by 100. And you get 4464. Just check that it's in the right time frame before I move on. National insurance payment weekly, and it was weekly, so I'm done there. Part B, Alana pays 7.5% off her gross pay into her pension. Alana's tax is 9206, calculate her net pay. Now, we've worked out the pension, national insurance in Part A, so we just need to work out the pension from £800, because it's always from 800. So it's just 800 times 7.5 divided by 100. Now remember, we could have done that with the decimal thing by changing that to a decimal first. 7.5 divided by 100 is 0.075. And I'm just putting this in here now for those of you that are moving on to higher apps. It's worth doing that and then doing 800 times 0.075, which is £60. But obviously it works exactly the same. If you do 800 times 7.5 divided by 100, you get £60. So there we are. So our pension's 60, so our net pay is her full wage minus everything that she's taken off. So we're taking off the pension, we're taking off the weekly income tax, just make sure everything's in the same time frame, and we're taking off the weekly national insurance of 4464. So we just get our calculator to work out that sum. Putting it all in the calculator correctly, we get 603.3, but money is 2 decimal places, so you need to put a 0 on the end, or you will lose a mark. SQA National 5 Application of Maths 2025, Paper 2, Question 5. A sports company sells squash balls. They're in the shape of a diameter of 4 centimetres, and they're put in cardboard boxes in the shape of a cuboid. Each box contains 2 squash balls. Calculate the volume of the empty space in the box. So that means I need to calculate the volume of the whole box. take away the volume of the balls, and see what's left. Now, start of exam paper, volume of a sphere, which is what the ball is 4/3 pi r cubed. So I need r, so straight away, not let myself be tricked. Diameter is 4, so r is 2 centimeters. So that means that I can now do what I need to do, which is my whole volume, the volume of the cuboid, we'll call it, minus the volume of the sphere. Now I know a lot of you will do this in 2 steps, so we've got the volume of the cuboid, well that's just length times breadth times height, so 8.6 times 4.2 times 4.2, and I'll not round till the end. So that is 151.704. And then the volume of my sphere, well, I'll say spheres because there's 2 of them. So that's 2 times 4/3 times pi times our radius cubed, which was 2. I'll put units on at the end. You could put it on as you go if you really want to. Times 4 divided by 3 times my pi button times 2 cubed is 67.0206 centimeters cubed. So the volume of my space is just 151.704 minus 67.0206. 84.6834 centimeters cubed, or if you want to round, 84.7 centimeters cubed, or 84.68 centimeters cubed, and we're done there. Now obviously I've not rounded until the end, so obviously I try to keep my numbers quite long so that there's no rounding errors as we go, but I wouldn't worry too much about it. So continuing with question 5, the boxes are packed into crates for transportation. They have to be this way up, 8.6 by 4.2, 4.2 is our box, and the crate is 100 by 75 by 40. First thing to check is, are the units the same? They are, so I can continue into my method for this. We have to calculate the maximum number of boxes to be packed into the crate for part B. So this is a box packing question. So I always just draw a little table here. I've got option 1, and I'll always put first the thing that cannot change. So the thing that cannot change is, it has to be this way up. So it always has to be 40 up the way. That can never flip. So that's what I'm going to put first, the height. And we start with a big number, and then we'll just say length and breadth, call them anything you want. So length is 100, breadth is 75, say. Now since the height is fixed, I'll just put a wee mark there just to remind myself more than anything else. The height is fixed, so that one always has to be 4.2. So we do 40 divided by 4.2. Because that can't change. Can't put that into that box any other way except up that way. So now we've got 100, so we can do 100 divided by 8.6, length against length. And we can do 75 divided by 4.2. And we'll just work out the answers to all of them. Now remember, you always round down because you can't get bits of boxes. So 40 divided by 4.2, 9. 100 divided by 8.6, 11. Ignore the decimals. 75 divided by 4.2, 17. That's option 1. Now let's do option 2. Well, option 2, 40 divided by 4.2 has to happen again because that can't change. And then we're starting with 100, we're starting with 75, and all that happens is you can change the position of the numbers. So 8.6 goes on the bottom, and 4.2 goes up the top. And now you can see that I've done all the options because I can't change them again. If you could change all 3, you would get lots more options. So 100 divided by 4.2 is 23. And 75 divided by 8.6 is 8. So there's our options for option 2. And then at the end, to work out the number, you just times them together. So for option 1, 9 times 11 times 17. For option 2, 9 times 23 times 8. Option 1 is 1683, and option 2 is 1656. So the max that you can fit in is equal to 1683. And we're done there. Continuing with number 5, the company looked at the length of squash matches, and a sample of times and minutes for professional matches are shown below. For these, calculate the mean and standard deviation. It then says the length of time for an amateur match. The average anyway, the mean is 42 and the standard deviation is 7.2, so we have to make 2 comments. So I always use the formula sheet, standard deviation, the sum of x minus x bar squared all over n minus 1. There's another option on the formula sheet, but I prefer to use that one instead, because I think that one's easier to work with. So we draw a table for this. X, our numbers are 52, 68, 45, 52, 58. So being careful and note them all down, 52, 68, 45, 52, and 58. First thing I work out is my mean then, which is in the formula is the x bar part. So you can just add them all up and divide by how many you've got. 52 plus 68 plus 45 plus 52 plus 58 equals 275 divided by 5, 55. So then in the middle, you do x minus x bar, and then you're going to do x minus x bar all squared. So let's get my calculator for that. 52 minus 55, always use your calculator. 68 minus 55, 45 minus 55, 52 minus 55, and 58 minus 55. Now we need to square each of these numbers. Little tip, don't put minus 3 squared in the calculator unless you're really confident that you're using the correct brackets. If I do that, look, minus 3 squared, it tells you it's minus 9. It's not correct because it's done 3 squared and then put a minus in front. It should have done minus 3 like that, squared, which is 9. Tip is, just don't do it. Just get rid of a minus if you're going to square a number and just do 3 squared, which is 9. So that gives me 9. 13 squared is 169. 10 squared is 100. And then we already know 3 squared is 9 and 9. So we can add up 9 plus 169 plus 100 plus 9 plus 9 is 296. And now we're almost done. Our standard deviation then is the square root of 296 divided by, well, there's 5 numbers to start with, so I'll take away 1, 4. Square root bracket 296 divided by 4 is 8.602. Or about 8.6. You can put your units in if you want. Minutes. You're not often penalised for it at this stage, so there you are. Part C, the mean length for an amateur match is 42 and the standard deviation is 7.2. Make 2 valid comments. So part C for amateur, mean 42, standard deviation 42 and 17.2. For a pro, the mean is 55 and the standard deviation is 8.6. Big difference. Okay, so when you're doing comments, you compare both. So for the mean comment, you always start with on average. And then check what the context was, the length of squash matches. On average, the length of squash matches was bigger, smaller, greater, fewer. I'm going to use longer, shorter because it's time. So in the amateur it was 42 and in the pro it was 55. Longer in professional matches. Compared to amateur matches. And I like because in brackets 55 is bigger than 42. So the length, I think you'll get a mark for just saying on average the length of squash matches were longer than professional matches. I always like to say compared to the other thing because you want to see you're comparing them. And then for standard deviation comment, that's about consistency. So the consistency of the length of the match. So amateur 17.2. That is quite spread out. The length of matches can vary a lot. Pro, a little bit smaller, so the length of matches is more consistent. So just like that. The length of matches in professional games of squash, if you really want to over-egg this, is more consistent than in amateur games. I probably misspelled amateur there, but you won't get a mark off for misspelling. And that's because the pro game was 8.6, which is less than the amateur game is 17.2. So a smaller number means more consistency. And we're done there. SQA National 5 Application of Maths 2025, Paper 2, Question 6. A badge has been designed in the shape of a right angled triangle with a semicircle. The outside edge of the badge is made of silver. Calculate the length of silver needed for the outside edge of the badge. So the outside edge of the badge is all the way around the outside. So all the way around here. So the problem I've got is I've got two sides, but I've not got this bit. Now that's a semicircle. Circle is circumference. Pi times diameter. So for this one, since it's semicircle, it'll be a half of pi times diameter. So I need the diameter. Well, the diameter is just this line. So that's a right angled triangle, so it's Pythagoras. So let me label that side x. X is just going to be, well, x squared is going to be 6 squared plus 9 squared, because I'm opposite the right angle is the longest side. So x is the square root of all that. So you can just do all that in a calculator in one go. Using a bracket, 6 squared plus 9 squared. $18.816. 10.816. If you prefer, 6, it goes on for a bit. If you prefer, you could have done the 6 squared plus the 9 squared first to get 117 and then done the square root of 117. You still get the same answer. So 10.8166 forever. I'll divide that by 2. So 10.8166, and that is the diameter. So I'll just round that to about 10.8. So I don't want to use a massive number there, do we? 10.8 centimetres. So that means that our circumference part is a half times pi times 10.8. Half is 0.5 times pi times 10.8 is 16.9646. 16.96 or 17.0 centimetres. I'll put 17, I think it's a neater number. So that means that my perimeter is just 6 plus 9 plus 17. which is 32 centimetres. And we're done there. Now, if you didn't use 17, if you did use 16.96, you would just get 31.96, and I'm sure that would be fine as well. If you had used the big long number, 10.8166 times 0.5 times pi, you would get 16.99. So you get 0.99. So in any case, you're getting round about the same answer. Even if you use 3.14 times 10.8 something, 16.956. So about 16.95, which rounds up to 17, even if you add in the 166. So either way, you're getting about 17. So there's your answer. 17 plus 9 plus 6, or thereabouts. Question 5, Application Maths 2025, Paper 2, Question 7. James travelled from Southampton to New York by ship. It took 180 hours, so he's in Southampton. And he's going to New York, and that journey is 180 hours. The local time in New York is 5 hours behind Southampton. The ship arrives in New York at 0400. 0400, that's New York time, on the 18th of November. Calculate the date and time the ship left Southampton. Date and local time the ship left Southampton. So I need the time in Southampton. So I need to take away 180 hours. And then I need to account for the time difference. So let's just check. 180 hours is 24 hours a day, 7.5. So if I do 180 divided by 24 hours in a day, I get 7.5 days. That's equal 7 days and 12 hours. But remember, New York is 5 hours behind, minus 5 hours. So that means that Southampton is plus 5 hours. So since I want to go back to Southampton time, I'm going to need to add 5 hours. So on the 18th of November, minus 7 days equals the 11th of November at 0400 so far. And then I need to take away 12 hours. So if I take away 12 hours, since clocks go in 12 hour times, 4 o'clock in the morning becomes 4 o'clock in the afternoon the previous day. So I need to take away the day as well and say I'm now on, well, 24 hour time, 4 o'clock is 1600 or 4 p.m. if you prefer. But now I need to take into account the time difference because that's a New York time still. So I need to go plus 5 hours for Southampton time. So 16 becomes 17, 18, 19, 20, 21. 10th of November, 2100, or 9 p.m. if you prefer. And we're done there. Then in question 7, James spent time in New York, then travelled to Toronto, Canada. And it says that the rate of exchange for a pound to US dollars was 1.28, and he spent all this stuff. He changed £1,500 to dollars. He spent $130 per day for 7 days, and he changed the remaining back to Canadian dollars. He then received $1,363.50. Calculate the exchange rate. That's different. So let's try this. We need to work out how many dollars he got to start with. So part B, we've got 1,500. We change it to dollars, so we times by the exchange rate of 1.28. That's 1920 USD. He then spends 130 times 7. That is 910. Spent. So left is 1920 minus 910. Which is 1010. So we now know that 1010 US dollars equals, it gets told, 136,350 Canadian dollars. Canadian. So if I want to know what 1 US dollar is, well, I'm just dividing by 1010. So I just need to divide this by 1010. So 1363.50 divided by 1010 is 1.35 Canadian dollars. Just like Canadian. And we're done there. National 5 Application of Maths 2025, Paper 2, Question 8. The start of an orienteering course is being planned. Competitors leave start point and run on a bearing of 335 for 400 metres to A. They then, from A, run on a bearing of 30 degrees for 320 metres to B. Construct a scale drawing to illustrate this part of the course. Use the scale 1 centimetre as 100 metres. And let's go. So taking a lot of information before we start, it's 335 degrees for 400 metres, but 100 metres is a centimetre. So we've got 335 degrees, 400 metres, which is 4 centimetres. It then said 30 degrees, and the distance for that was 320 metres. So I divide that by 100 to get 3.2 centimetres. I want to draw 335. I have to put my protractor on, but if I do that and go to the right like I meant to, I want to go around 180. So I'm going to have to work out the difference to go to the left. So I'll need to do 335 minus 180. Which is 155 degrees. So when you're going past 180, I'm going to have to extend my north line. So you just get your pencil and draw a nice vertical line going down the way. And now that I've extended it, I can take my protractor and I can take it to the middle and turn it round so that I can get in there to draw all the way around the other side. Line our protractor, making sure it's going through the zero. And we've just worked out we need to go all the way around to 155 degrees. So that is up there. So we'll just make a mark up there on our page, and then we join it up with a straight line. Line my ruler up, and I want 4 centimetres. So I'll just draw a nice 4 centimetre line, as accurate as I can, and then we get rid of the ruler. So the next one we have to draw is 30 degrees for 3.2. So we need another north line at our new point. So that's point A, remember. New north line, starting again. We need to draw 30 degrees. So we get a protractor, goes in the centre, through the zero, as best you possibly can, and make a mark at 30 degrees. And then join it up. So I've lined my ruler up through my mark. And remember that was 3.2 because it's 320. So 3.2. Get rid of the ruler, and that's point B. Now we can label this and stuff. So between here and here, we've got, and that was 400 metres, which is 4 centimetres on my diagram. And then we've got 30 degrees here, and that was 320 metres, which is 3.2 centimetres on my diagram. Now usually we then ask you to work out the distance going back, but it doesn't tell you to do that in this question. But if you were to do it, you would then just join up the points from here back to there and measure that distance. Then you'll just get your ruler and then times it by 100. And we're done there. SQA National 5 Application of Maths 2025, Paper 2, Question 9. McKay Marketplace is a grocery shop. All the tills in the shop have a weighing scale. An object weighing 800 grams is placed on the scale. Regulations state that the scale should display a reading of 800 plus or minus 0.05%. The scale displayed 800.6. Does it meet the regulations? So for this question, we have to work out our max and our min because this is tolerance. Max and min. So I need to work out at the side 0.05% of 800. So that is 0.05 divided by 100, because I'm percent, then times 800. So it's quite a small number. That's just 0.4. So our max is 800 plus 0.4, 800.4 grams. Our min is 800 minus 0.4, which is a little bit trickier, so I'll just use a calculator, 799.6. So you can only be between the two numbers. Since 800.6 is bigger than 800.4, it does not meet the regulations. And we're done there. The shop sells lemonade. There are two options. Option A, 24 pack of 250ml for $7.50. Option B, 10 pack of 330ml for $3.89. Determine which shop offers the best value for money. So we're going to have to compare like for like. So we're going to have to get the same amount of liquid and how much that costs for each shop. So let's look at option A first. We've got 24 packs. So how much liquid is that? 24 times 250. That's 6,000 millilitres. And for option B to start with, we've got a 10 pack is 330 millilitres. That's 3330 millilitres. We can work out the cost of 1 millilitre, but that's going to give us a very small number, so I'll probably scale it up to make it look nicer. But we do know that that equals 750, and we do know that that equals £3.89. So to work out 1 millilitre, you would do 750 divided by 6,000. I'll show you what that looks like, because you might have done that in the exam. You get 0.00125, and you would do the same for this one then. 389 divided by 3330 is 0.001. I'll just round it to the same number of places, 1168117. So you might be able to see that one's smaller than the other. I can see that B is smaller than A, but if you can't, maybe just scale it up to 1,000 millilitres. And 1,000 millilitres would be an idea just by timesing by 1,000. Because if you do that, it'll be easier to see. 0.00125 times 1,000 is £1.25. And 0.00117 times 1,000 is £1.17. And now it's much easier to see that £1.17 is less than £1.25. So, little statement, determine what option offers best value of money. Option B, best value, as £1.17 is less than £1.25. And we're done there. At Christmas, the shop puts up decorations. Last Christmas, it took 6 workers 5 hours to decorate the shop. This Christmas, there are 8 workers available to complete the same task. All workers decorate at the same rate. How long will it take to decorate the store? Hours and minutes. So we know 6 workers is 8 hours, 5 hours. Now, to get 1 worker, you don't divide by 6, because this is reversed. This is inverse proportion. When you're doing work, you scale up by timesing to see how long it takes 1 person. So 1 worker is 5 times 6, which is 30 hours. So that means that 8 workers is 30 divided by 8 to get back to 1 worker. So usually you would times by 8, but again, inverse, we're doing the opposite, so we divide by 8. 30 divided by 8 is 3.75 hours. So that is 3 hours, and then you just take your 0.75, and since it's 60 minutes in an hour, times by 60 to get 45 minutes. Or you might have known that that was 3/4 of an hour, but there we are, we're done there. Okay, 9 continued. Freya works for McKay Marketplace. She's contracted to work 35 hours per week. Her basic rate of pay is £10.60. She's paid double time for overtime she works, and last week she worked 39.5 hours. Calculate her gross pay. So we need to work out her overtime hours. So that's 39.5 minus the 35 she already does, which is 4.5 hours. So to get her pay, well, we've got it made up of two components. Her basic, which is 35 times £10.60, and our overtime, which is 4.5, because it's 4.5 hours, still times £10.60, but then the double time comes in. Double means double. If it says time and a half, you times by 1.5. So we do the two sums and then add our answers together. 371 for the first one, and 95.4, £95.40. Add these together. We get £466.4, £466.40, and we're done there. SQA National 5 Application Maths 2025, Paper 2, Question 10. Andy runs 3.4 miles in a time of 33 minutes. Calculate Andy's average speed in kilometres per hour. And it says a mile is 1.609 kilometres. So speed is distance divided by time. But we want it in hours. So to change our minutes into hours, 33 min equals 33 out of 60 hours. So you just do that in a calculator. 0.55 hours. And then we want to change our miles into kilometres. So lots of work to do before we even start. 3.4 miles, well, it says 1 mile is 1.609. So 3.4 miles is 3.4 times 1.609 kilometres. Which is 5.4706 kilometres. So then our distance is 5.4706 divided by our time, which is 0.55. .99465 kilometres per hour. I'll just round that to about 9.9 kilometres per hour. And we're done there. B. To improve his fitness, Andy wants to complete house sprints. The hill closest to his house has the following measurements. Horizontal distance between the top and bottom is 250. The bottom of the hill is 48 metres above sea level. So you can imagine that we've got the sea down here, and that's 48. And then the top of the hill is 71 metres. So to get the difference, I'm going to have to do 71 minus 48, which is 23. Because it's 71 also from C up to the top. So 23 plus 48 is 71. It then says, his training program states the hill must have a gradient greater than 0.1. So to work out the gradient, to see if it meets the requirements, we need to do gradient equals vertical over horizontal from the start of the exam paper. And now I've just done the work to work that out because I've got my 23. So that's just 23 over 250, which as a decimal, 23 divided by 250 is 0.092. So no, doesn't meet requirements. As 0.092 is less than 0.1 because it's not 0.1 yet. And we're done there. And question 10C. After starting the training program, Andy could run 5.6 miles in an hour. After question 10 continued, before starting the training program, Andy could run 5.6 miles in an hour. After completing the program, he could run 7.2 miles in an hour. Complete calculate the percentage increase in the distance that Andy can run in an hour. Okay, so percentage difference is like a fractional increase. So I will need my difference between the end and the start over the start. 7.2 minus 5.6 is 1.6 out of 5.6. So 1.6 out of 5.6 is that number, but then I need to times that by 100 to get a percent back. So that equals 28.571%, or about 28.6%. And we're done there. Clear Maths. Today we've done National 5 Applications of Maths 2025, Paper 2, the full solutions. Quite tricky to get that done on camera, especially with all the diagrams that you need to do and the measuring and stuff, but hopefully you found that useful. See you soon.